One of the most exciting products that we've unveiled here at IMTS 2016 is the Vereo Smart Integration Laser, which is the latest revision to our Vereo laser system. This is an integration laser, but it is packed with a ton of great new features, including a very proprietary control system that is game-changing. It enables the user to control and monitor their integration laser on the same network from any device, including smartphones, tablets, or your desktop or laptop PC. Additionally, we have new control capability for connecting to PLCs for data transfer, and that includes some of the most common brands on the market, such as Siemens and the complete Allen Bradley line. One thing I do want to show you though before we get into those features is we've also completely redesigned the head. It's more compact than our previous version, it's more robust, it's more sealed, and it's more harsh environment proof than ever before. The head is made of machined aluminum, extremely heavy duty. We have new cable protection. We also have indication lights on top to alert the user if the user is outside of a cell, an automated cell where the laser is integrated. You can see the current status of the laser just from a visual standpoint. We've made the laser a little slimmer from left to right, a little less long and a little less tall. So for those tight integration spaces where you need to get the laser head in to do the marking in a online process, a automated production cell or a robotic cell, it's very, very ideal for that. The Vereo Smart Integration Laser is completely standalone. This means that it requires no PC. So the marking programs can be created and loaded onto the machine. Now you can see here we have a touch screen control on the front. That is your first layer of controlling this system. We have the ability to go in and not only see all of the marking programs that are on the system. By clicking here, you can scroll and you can see the various jobs. For example, I'm on job 5. If I want to load job 4, I can do that. You can see the job has changed. I can also, even through this screen, change variable data through a keyboard. So if the operator has a pre-existing program or the engineer and they just want to change some basic marking information, they can do that very, very easily. We can even get a preview of what the marking file looks like for quick reference. Now there's a variety of other things that you can do here. You can trace so that you can do your alignment and your setup. You can start the marking, stop the marking. There is a variety of protocols on here and communication protocols that can be set up for data transfer, monitoring, and a lot of flexibility. From there, we go to the next level of control, which is through our embedded web interface, which we will show you next. Again, one of the most exciting features that we've introduced with the Vereo Smart Integration Laser is the ability to control and monitor and even set up your laser system from almost any device on the same network as the laser. The laser itself can be added to the network via Ethernet, and any device such as a smartphone, a tablet, a laptop, or a desktop PC can connect to the laser remotely on the same network. Therefore, you could be on the other side of the factory or even just outside of the work cell and have complete control over your laser system. All we do is we enter the IP address along with the port, and then we can access what we call our embedded software interface to control the machine. And this can be password protected so that you can restrict the users that can access the laser over these types of devices. You can see here we're showing you on a simple Android tablet. It also works as well on Apple products, basically anything with a web browser, and there's no additional software to install. We have a variety of capability on here. One of the highlights I want to show is that we can go right here to the PLC wizard and within a couple minutes instantly put in the important information for the laser to be able to connect to common brand PLCs such as Allen Bradley, Micrologics, Control Logics, Compact Logics, as well as Siemens and more coming very soon. You simply put in the IP address of the PLC, set up your data tag information, your heartbeat information, and that's unlimited. You can program a variety of tags. You click submit, the laser automatically is configured at that point to connect to your PLC. Once it sees your PLC on the network at that IP address, it'll connect, and data transfer as well as program selection can happen seamlessly with the PLC and the laser system to change the data and again change the marking programs. If we go home, we have a variety of other capabilities. We can also go to a web client where we can change the current project running, change its variable data, and even see a preview of what that project looks like. Next, we can showcase our API command list. These are commands that can be programmed from an existing software package or data package on the network, such as an ERP system, which allows a programmer some very simple commands that we've developed that send over the network via HTTP to do all types of actions, such as start the marking if they wish, stop the marking, get a current list of all the available jobs on the laser, as well as load jobs, change data, and a variety of other capabilities. We can change the settings, and we can also go to a file upload. If I'm an engineer on the other side of the factory, I can sit at my desk with our MiniLace Pro SE software package, create a brand new marking program, choose that file, and as we're on an Android, you can see here that we have a variety of files available, but you would normally be for this on a desktop PC. You would choose that file, upload it, and that file now exists on your laser system and is ready to run. And again, that can be done from your desk on the other side of the factory as long as you're on the same network. We can also see the available jobs and delete them from here. Lastly, and most importantly, we can monitor the performance of the laser. We have a log file. So here you can see we have a running log of all the actions that happen with the laser, all the data that's been transferred, all of the marking that's been completed, everything, all the signals for discrete I/O, such as start, stop, shutter, open, close, etc. And we have a historical record of every date that the laser's ever been in operation, and we can go down with a time and date stamp and find out what our laser has done in the past. Let's say you had some part issues or some data that was wrong, you can go back and trace out, find out where that problem occurred. Additionally, we have a status. Now this takes a little longer to load because it pulls down a lot of information, but on the status screen, there's so much that we can see and do and monitor with our laser system. We can see how many of each program has been processed, how many times it's been run, the status of our PLC, which is connected, which we'll show you here in a minute, with the Allen Bradley PLC, the IP address, that information. The onboard processing system that controls the marking programs, we can see the RAM usage, the hard drive space, the number of files that are on the system, information about the software, whether we're controlling axes, and we can also see the type of laser system, the laser serial number, the amount of running hours on the laser, as well as the current diode temperature. So there's a lot of flexibility for supervisors, managers, and engineers is to monitor the laser system and find out what's going on in real time with your system from any device, from your mobile phone in your pocket, to your tablet, to your PC in your office. As we just showed you a few moments ago, it's very easy using our control interface to connect to the laser and set it up within a few minutes to connect to your PLC over TCP IP connection on the network, or direct connection even, and start communicating instantly with your PLC for marking program changes, as well as changing the data in the marking program. So if you have a variable serial number, for example, or a code that's generated from a leak test machine, and that is stored on your PLC, you can instantly update that on your marking program through our connectivity to the laser, which again takes only a few short moments to set up. So there's no complex programming or scripting necessary to accomplish this. What we're showcasing here is that we are connected to an Allen Bradley PLC inside of this enclosure. We've went one step further and added an Allen Bradley HMI, which you can also link to the PLC and put outside of your work cell. So if you're outside the gate of a protected work cell and you don't want to use our embedded interface or don't want to go in the cell and change the information on the touchscreen, we've shown that here that you can even set up a very basic screen on your Allen Bradley HMI that will allow you to change the current marking job manually this way, which I just did by selecting a different job and hitting enter. You would see on our laser system feedback screen at the bottom that the job is switched to QR code.